For decades, drinking water safety depended almost entirely on centralized treatment plants. But today, a new model is emerging, one where the final and most precise purification step happens directly at the point of use. Beneath the kitchen sink, a modern multi-stage filtration system is not just a filter. It is a compact, engineered barrier system designed using the same principles as large-scale environmental infrastructure. Each stage removes a specific class of contaminants. Together, they create redundancy, reliability, and precision. This is the multi-barrier approach, scaled down to the household level. In water safety, no single treatment process is considered sufficient on its own. Instead, environmental engineering relies on multiple independent barriers. If one process becomes less effective, the next continues protection. At the household scale, this philosophy becomes even more important, because point-of-use systems act as the final defense between contaminants and human consumption. Multi-stage filtration is not about over-engineering, it is about risk management. The first stage focuses on particulate matter. Even in treated municipal water, small amounts of rust, scale, and suspended solids can be present due to pipe aging and flow disturbances. Sediment filters protect downstream components. They prevent clogging, they stabilize performance, and they ensure that advanced stages can operate at maximum efficiency. This is a mechanical protection layer, simple but essential. The second stage targets dissolved chemicals. Activated carbon is one of the most widely used materials in water treatment because of its enormous internal surface area. It removes chlorine and disinfection byproducts, volatile organic compounds, taste and odor-causing substances. But at this scale, carbon is not just improving aesthetics. It is protecting membranes and nanomaterials in later stages from chemical degradation. Each layer prepares the conditions for the next. The membrane stage is the core of the system. Reverse osmosis creates a physical barrier at the molecular level. It removes microplastics, heavy metals, nitrates, pharmaceutical residues, dissolved salts. This is the point where water quality becomes independent of upstream infrastructure conditions. Regardless of what happens in the distribution network, the final product remains consistent. This is decentralized precision treatment. Highly purified water is chemically unstable. It lacks buffering capacity and can be corrosive to plumbing. Remineralization restores essential minerals such as calcium and magnesium. This improves taste, pH, stability. Long-term compatibility with household systems. Water is not only about removing contaminants, it is about creating a balanced and biologically compatible final product. Even after advanced filtration, microbial safety must be ensured. Compact UV systems provide a final disinfection barrier. They inactivate bacteria and viruses without adding chemicals. This prevents regrowth in storage tanks and internal plumbing. In multi-stage design, the last barrier protects everything that comes after it. Performance does not depend only on design, it depends on operation. Smart monitoring systems measure Flow rate, filter lifespan, water quality indicators, they notify users when replacement is required and prevent performance decline. In advanced systems, maintenance becomes predictive rather than reactive. This is how engineering ensures long-term reliability at the household scale. Beneath the sink, a complete water treatment plant is already taking shape.